Okay, so you have two choices. Your two choices are you can take a third exam. That third exam will cover only correlation and regression. Okay, and be similar. I posted a final assignment, which is a very short assignment on just a simple linear regression, simple linear correlation and linear regression. Really simple. It might have a couple of problems like that. It might have some multiple choice on it and so on and so forth. It won't be a really comprehensive exam. It'll only be the material since the last exam, which is primarily just correlation and regression. You have a choice of taking that exam. Rules will be same as always on the exam. Open book, but you can't collaborate with anybody. You have to do it on your own. You'll have 2 shots at it. It'll be timed for 2 hours. You have 2 shots at it. It'll be posted on Monday morning. You'll have until Friday end of day to complete the exam. Technically Thursday, but you can work on it on Friday if you want. The end of the finals period is actually the 19th. So I put a due date. Actually, it's Thursday, not Tuesday. I'll correct that. Put a due date of December 19th, but you could stretch it down 1 extra day. But I do need to work on the grades over the weekend and get them in on Monday. So I can't stretch it beyond that. Okay, so you have a choice of taking that exam or doing a project. I think you're better off doing a project because I think it'll exercise your mind a little bit more. It's a little bit, it gives you an opportunity to actually apply what you've learned here and maybe get to feel a little bit more comfortable with it using SPSS and so on and so forth. Okay, so and applying the statistics that you've learned. Okay, now you can use Word or PowerPoint or anything you want to produce this report. The report can be 5 to 10 pages, mostly relatively, including graphs or charts or anything else you put in there. And you'll be creating that, and if you want, you can post it to the discussions board to get feedback from other students or from me, for instance, right? If you want, which wouldn't hurt, because if you do that before you actually submit it, you may get some good advice on it and so on. You can use text, and so initially this is intended to be a poster. Did you guys just have a poster session? They had a poster session here, right? So you got the idea. People who were posting, describing their research, their capstone projects, and so on and so forth. So what did they have in those posters? Well, on your poster, you could format this as a report or a poster, it doesn't matter. On your poster, and by poster I mean, if you want, you can make it up on individual PowerPoint slides. On your poster, you want to put an introduction, a brief overview of the problem, what its significance is. You don't need to do a full literature review, but you should include references, 1 or 2 references on published papers on the topic. So one of the topics here that you can choose from, which is, and remember, I'm going to be giving you a few options that you're going to see here. You probably saw them already. Among those options are going to be stuff that there's going to be a data set that's already kind of laid out for you and ready to go, right? That influenza data set, right? So there's a certain, in the Olympics, there's a certain benefit you get based on, the degree of difficulty, right? So in other words, if you go out there a little bit and like make it and do a little bit more and increase the degree of difficulty, like maybe look at other variables and do something unique or something like that. If you stumble a little bit, it'll be easier for me to overlook that, right, and grade it a little bit more leniently. So I will consider the degree of difficulty if you decide to extend yourself a little bit. Okay. So you said this says overview of the problem, a couple of papers. So you can go online to go on PubMed or something like that, and maybe look up something recently about influenza outbreaks or the compliance with vaccination. In other words, so if you're using that data set to examine whether or not people who are insured are more likely to get a vaccine, well, then maybe you want to find something, a reference to an article that it's associated with that in some way, like who goes for a vaccine, who doesn't go for a vaccine, and that kind of stuff. But you'll be using the data in our survey to actually examine that, right? Okay, and then do some descriptive statistics. So in other words, if you are looking at the association between insurance and whether a person is more likely to get vaccinated, you might want to put a table up there or a bar chart or something like that, or a histogram that gives you an idea of what the distribution of the people in your study are. Are they mostly male or female? Are they mostly insured or non-insured? What kind of insurances do they have? Like both bar chart, she's well, like 60% of them are private and 30% Medicare. Like use tables or charts to describe, give us the descriptive statistics and describe the population that this is coming from. Don't gotta get crazy, but it's something that tells us something about it. Could be just tables, could be tables and charts. Net methods, describe the methods used in data collection. In other words, remember that there's a code book and there's also a questionnaire that goes along with the New York City Community Health Survey. Describe how they collected data. What did they do there? Maybe a short paragraph on how the data was collected, where it came from. Okay, and then tell us about what statistical methods they use to analyze this data. Did you use a chi-square analysis? Did you use compare the averages of two populations? If you use the numerical variables. So what we're looking for here is we're looking to see that which statistical test you should use to do a specific analysis based on what kind of data that you're working with, categorical data, numerical data, and so on and so forth. Okay, results. Show your results. What was the result of your test, your t-test, p-values? What about graphical representation of your results? Okay. What you found. Discussions includes briefly summarize your findings, provide final remarks about the relevance of your conclusion, include your thoughts about the limitations of the study and future directions. Like, in other words, they could have asked this question. I would have in this survey, they could have asked this question. It would have been enlightened us a bit more. And like I said, include just one or two references. Okay, based on clarity, correct interpretation of results, appropriate statistical methods. So option one, flu shot utilization in New York. We have a data set already prepared for you. We're also giving you the full community health survey data set. Okay, if you see another set of variables in there you want to pursue, then go ahead and do that. If you want, you can always email me or post on discussions board about whether you're headed in the right direction with that. Okay, so I'm going to show that to you. So in the data set that's prepared for you, that's already coded, the variables are flu shot, received it in last 12 months, yes or no, type of health insurance, race or ethnicity, borough of residence, poverty rate in the neighborhood that they live in based on their zip code, their gender, their age, whether or not, it's called nativity, whether or not they were born in the United States, and whether or not they have children, any children younger than 18 living in their household. Right. So I know, when I used to be around kids more, I get sick every year. So I'd be first one lined up for a flu shot. Okay, data source. Yeah, they're like petri dishes. Data source, community health survey. Okay, that's the survey. And option three is you can choose your own study. If you have data from another class you're taking or from your capstone, you can present that here also. Okay, in this format. Okay, that would be great too. Except remember, I'm looking to see how you analyze the data. Your capstone report might be 20 pages on what you did and the science and so on and so forth. I'm only interested really in the basics of what you did and how you analyze the data, right? That's what you're keyed in over there. When your statistical test on your capstone was a little minor part of it. Over here, it's the major part, and the capstone's the minor part. Okay? So if you have something like that from another class or from work or from some other data set that you can obtain or use, that would be great. So I'm going to look now at the data sets that we have provided.
So it's both a paper and a presentation?
No, there's no presentation because unless you're going to do it in the bedroom and film it, normally what this was going to be, right? The word presentation is in there because when we were brick and mortar, what we would do, even hybrid, we used to, when this course, we call it hybrid now because you guys get to come in for a couple of hours. But we used to do a 3-hour session, like brick and mortar. And what we used to do is on the last day of the class, you had to show up, even though it was up mainly online. You had to show up for the first class, the two exams, and the final presentation. No final, just a presentation. So you did this. You printed this out on paper, and we had foam core board, right? That you could mount it on with tacks and stuff, so it looked like a poster, right? Well, there's no requirement in this course to come in here. If you're taking this course from Idaho, you can't come in here for 4 sessions, So in other words, sometimes we give this course that, in other words, when you take this course, you got the ground rules, you saw the syllabus. And the syllabus told you didn't have to be here ever, right? Exactly. So now that ties my hands. I can't make you come in, right? So it would have been great. And what we do, it literally takes us sometimes 3 or 4 hours on the last session. And we would have every student spend 5 minutes in front of his poster and present his data, tell us what he did, tell us, unfortunately, when we would give that flu data set, it was a little bit annoying because half the class would do that flu data set. It's got a little repetitive, right? But they all did they all did something different. They all presented the data differently. All of their charts or graphs looked a little bit different. All of them approached it a little bit differently. So it's still interesting, right? But so that's where this comes from. Except now it has to be a paper that you can upload, and you can do it as a PowerPoint, like individual sheets that almost can double as a poster, right? Because if you look at a poster, they look very much like a PowerPoint, just glued up onto a board, right? An introduction, tables, charts, another section over here, another section, right? So yeah, you could do it that way. You could just do it as a paper, physically as a paper. Right? So you get the choice on that. But I want to show you what data that you have available for you. Now here's the exam. Actually, this is exam 2. What?
You provided some examples of previous
posters. I don't know if I did or not.
I thought I had seen a couple.
Yeah, I don't know if they're still up anymore though. Yeah, I will put something up. I'll find something. I got to find something that is unique, so that I don't want you to duplicate what somebody else did.
Right.
Yeah. I'll find some. I will post something. I will post something that is a little bit more unique. So this is kind of ground rules on the project and so on and so forth. Let's see. Oh, this is wrong class. That's why I'm having trouble with this. 625. Let me get into our class and our paper. Yeah, I'm showing you the wrong one.
How many classes do you have this semester?
Yeah. What's that?
How many?
I have 5. That's unusual. The person I usually teach with is on sabbatical. He went through cancer treatments,
Right.
and he's recovered, but he's on sabbatical. So I had to wind up picking up a course or 2. So yeah, this was a busy semester for me. Next semester I only have 2 classes, so I'm actually a bit relieved about that.
Thank you for submitting the exam grades.
What the? I got to do it anyway. Okay, so let's take a look at this. Here we go. Here's our project option. So your exam will be here on Monday, right? And the project is available now. Okay, so you can go in there, and here is a description of your project. It's going to I was looking at the wrong document there. It's going to be pretty similar. Okay, right? Yeah, I opened the receipts. It's still. I don't know what I was drinking when I did this. Tuesday. I got the date right, but I didn't get the day. Because my other classes are on Tuesday night. Okay, but I knew it was the 19th. Okay, yeah, it's basically the same thing. Right? So, flu shot utilization, it's the same document. Okay, so let me show you the data sets that we have that you can work with. Okay, so one of the data sets, for instance, is the Community Health Survey, a simplified flu data set that's coded already. So I'm going to open that in SPSS. Unfortunately, I'm going to have to. I wonder if I can just drag that one. Let me just drag. I have two versions of SPS on here. And the default one that opens is the old version, which which is expired. And I haven't gotten around to taking it out yet. Oh, I just saved the same one twice. Okay, so let me go to SPSS and open these things. So you have one data set, community health survey. First of all, did I show you the community health survey where it's planted on the internet? New York City Department of Health. New York City Community Health Survey. See if it's that simple. Here we go, Community Health Survey. Okay, let me shrink this a little bit. Okay, here's the Community Health Survey. It's NewYorkCity.gov. You saw all I had to put in there was NYC space CHS Community Health Survey. Every year, New York City Department of Health does a community health survey. They call 8,000 people in the city of New York on the phone, and they go through a questionnaire of 160 questions with them. They don't, in other words, some of the questions though, do you smoke? If you say yes, do you smoke? There might be 8 other questions. Yeah, exactly. So not everybody answers 160 questions, but they're on the phone for a period of time. I think they pay them something. I think, in other words, if you do the phone survey, they give them something. I don't remember what it is, but they get some benefit out of it. So they survey, excuse me? Yeah, you should. So they do this every year. So you can go in here, you can go to public use data, and you can look up this data set for, right now I have you working with 2013 because I already coded some of that. But you can go in here and get more recent data, and you can get the questionnaire that they use. You can get the data set. It's an SAS format, which can be imported into SPSS, but you lose some of the coding, right? Here's the code book. The code book just tells you if this variable, if it's a 1, this is what 1 means. This is what 2 means. This is what 3 means. Okay, so this is not something I made up. This actually exists, right? It's a real data, right? Exactly. It's a very large survey. So kind of interesting working with it, So at any rate, let me open up one of these sets. This is a simplified set. It only has about 9 or 10 variables in it. We took out well, let me open the real one first, so you can see what the real one looks like. Okay, file, open, data, oops, there we go, okay, open data. And there is Community Health Survey. I didn't save that one. Let me go back, make sure I got the full one. Full. There's the full version as a SPSS file. And let me save the code book. Make sure the code book is up there. I'm pretty sure I saved it already. No, it's not me. Okay, let's go to SPSS. Open data. And now we should see it here. Here is the full set. Okay, and here is the variable view. Look at all these variables. Right? Look at the data view. There's the data view, right? But look, you can barely tell what's here. This one over here, between me and you, I know what that one is. That's age, right? I can tell by the numbers there. That's age. It's called demog1, right? That's the variable name. So I'm going to go to the variable view again. And if I look over here somewhere, I probably could find, here's demog1 is the 11th variable, right? And that is, if you look under label, whoops. Yeah, what is exactly? You can probably start to read it there already. 11, what is your age? There you go, exactly right. That's exactly what they said there. Right, so that's a numerical variable. And you go over here and and SPSS coded it, it's coded properly. Yeah, but what about these other variables? Well, this variable, Oh, no, no, no. Yeah, no, this is uncoded. This is not coded. So for instance, if I go to the data view, right, all I see is the numbers. If I go up here to view and say turn on or turn off the value labels, it doesn't know what anything is, right? So how do you know what? So for instance, if I go through this and I say to myself, well, let's see, what can I, let's see. I want his type of insurance, right? For instance, let me find something else that's interesting. Smoking status. Um, um, let's see, age groups, nativity, right? That's one of the ones that we're working with. Marital status, body mass index. I guess they ask them for their weight and height. You know, which I over the phone, I guess I wouldn't count on that information being accurate. Yeah, there you go. There's a lot of interesting variables in here, right? Right. So for instance, if I wanted to know, now I'm gonna look for.
That's the only. Wait, I can see a blur. No.
Here, here's one. Here's one here. Here's one here. We can't test them for diabetes, but there's a question here. Can you read that? Have you ever been told you have diabetes?
Yeah.
So they might say yes or no. So we can assume that means they have diabetes, right? So now, but we don't know which one is which, right? So how do we know which one is which? Well, the way we know which one is which is that's on the third. The way we know which one is which is I'm going to go back to my desktop. If I can ever get there again, right? The way we know which one is which, there's a way for me to.
Yeah.
I'm trying to figure out this. I mean, nope, that does that. That doesn't help. I think it's an option on one of these up here. I forget. Yeah, I can't figure out which one it is. Okay, let me just get things out of the way for now. Okay, downloaded the code book. Here we go. So there's a code book, and here's the questions. So I'm going to open the questions first. And this is basically instructions for the person doing the survey. Okay, so here you go, health status, so on and so forth. So here, landline instructions. If you got to kind of skip to cell phone, exactly. It's important that they present this, ask the question exactly the same way. It's very scripted. That's the way you need to do a survey. You don't want to influence the answers, right? So you don't want somebody that's judgmental if you say, oh, if they ask them questions about sexual activity or something like that, right? You want them to be just plain vanilla, just ask the question and get the answer, whatever you have to do. So this is really where you'll see each one of these questions refers to the same question you saw in the data set. This other file is the code book. Okay, and the code book actually tells us the names of the variables and what the responses that have been recorded indicate. So we were talking about number 33. What was it? Diabetic, right? So each one of them, I'm gonna search. There's your fruit and vegetables. Okay. Have you ever been told that by a doctor, nurse, other health professional that you have diabetes? One is yes, two is no, and anything else is ignored by SPSS. One is yes and two is no. So I'm going to go back to my data set now. And I'm going to go, I think it was 32. I'm going to go into diabetes 13. Have you been told? One is diabetic, and two is not diabetic. You have to get add before you hit OK. Okay, make sure it goes in there. And now when I go to my data set, there it is. Well, hang on. Let me turn on value labels. Yeah, where is up? There it is, right there. Right. So now instead of the number, now it means something. Let's say you said, I don't want to do flu. I want to see whether diabetics are more likely to be insured or uninsured, or if there's more diabetics in the Bronx than in the other boroughs or something like that. Well, now you could use that variable instead. So now what am I going to do with all these other variables that are here? That I'm not going to use, right? Well, maybe I want age, maybe I want a couple of other things, borough, right? What am I going to do with all these other variables I don't want? Well, one of the things you can do is either here or in the variable view, just highlight them and say clear. And they're gone. So you can just narrow this down to only the variables you're going to use. Yeah. And then save it as a new file. Huh? Well, yes and no. If I said save and it saved over the file, that would be forever, right? If you say save as and save it as a new file and then don't save this version, then it's still there. But that's okay. You can always download it again because it's always going to be on black. You got it from black with us. Yeah, but that's your own data. There's nowhere else that exists, right? So if you want to be more adventurous, you can go ahead and do that. But if you don't want to be adventurous, there is, okay, if you don't want to be adventurous, you can instead file, open, data, use the data set that we've prepared for you, which is 2013 Simplified Flu Data Coded.
Right, and that's the one you coded yourself?
Yes. First of all, we removed a lot of the databases, a lot of the variables. The only variables here are age, borough, new race is race, basically. A new race because I think is a reduced set of races. Neighborhood group, that's poverty level, right? Insured or uninsured. Insured, what kind of insurance? Did you get a flu vaccine, yes or no? Gender, are you nativity US born or not US born? And whether or not you have children or how many children you have. This is kind of a funky one. This you might have to work with because you can see none, two, you know what I'm saying? It's not one and two. I don't think. Hang on. Oh, maybe it is. I got to turn it off. Maybe it is. Hang on a second. Yeah, it is. It is numbered. Yeah, it's 0, 1, 2. Yeah, one means no. One means no. One. Well, it just happens that it does. That's in other words the data. If you look at the data set, this is what the interviewer wrote down. 1, 1, 1, 3, 1, 3, 1, 2. What do those represent? Right. Hang on a second. Well, I can tell you what they represent. Just going to go into the variable view. And children, I can click into values, and 1 means none, 2 means 1. 2. Personally, I would use 0 for none, and then I mean it's kind of silly. 3 means 2, and 4 means 3. You know what I'm saying? It's kind of like it's a little funky. Yeah, that's okay because you're only as far as SPSS is concerned, it translates that for you. You don't have to worry about that because on all the charts and tables, it will substitute the right value for the number that's on there. 1, 2, 0, 1, 2, 3, 4. So anything you do there. So for instance, if I wanted to, let's see, any other numerical variables here. Children, that's kind of numerical variable. Insured, yeah. Well, we have age, right? What if I wanted to know if I wanted to demonstrate what the average age in the different boroughs were? Analyze, descriptive statistics, explore, and I'm going to put into the factor list, I'm going to put the borough of residence, and into the dependence list, I'm going to put the subject's age, and I'm going to say, well, help me out here, give me, okay, 95%, okay, let's do this, and here we go. Oops, here's my alpha table out here. Here's the box plots for different boroughs. Okay, and here you go. Here's the average age, and which do you think is the oldest borough? People with the oldest age. 47 in the Bronx, average age of 46 in Brooklyn, 52 in Manhattan. You need to, you got to save up a few more months to live, a few more years to live in Manhattan. Oh, look at that. Staten Island's pretty close, right? Very close. So how would you compare the average age of the 5 boroughs? My null hypothesis is that the average age in all the boroughs is the same. My alternative hypothesis is they're not, at least 2 of them are different. What does that sound like?
I'm
Bingo, exactly. Yeah, I'm so happy you're here. Okay.
Oh, I think.
Okay, so now I'm going to go into here into compare means, right? Compare means. And I'm not going to go to t-test because I have 5 groups, not 2, right? I'm going to go to one-way analysis of variance. And I'm going to say, okay, what am I going to move in there? I'm going to move into the factors. Well, into the dependence list, I'm going to put what we're taking the average of. And here I'm going to, the factors, I'm going to put borough. And I'm going to say, okay, and see what I get for my analysis of variance. And look, my F value is very high. There is at least 2 of these are different from one another, statistically significant. How do I figure out which 2? You remember analysis variance? How do we figure out, once we've got confirmed that we can reject the null hypothesis at the post hoc test? Yeah, okay, so I'm going to go to analysis of variance, compare means, analysis of variance, and I'm going to go post hoc test, and I'm going to pick Bonferroni. Either one. I love that. That's why I pick it all the time. Well, Tukey sounds like turkey, so I use that one on Thanksgiving. Okay. There's actually reasons for using each one of them, but we don't have to get into that. Okay, so now it compares each one of them. Actually does it twice. You know, goes through every compare, go Bronx to everybody else in Brooklyn. Okay, so what we're looking for here is we're looking for the ones where the significance is less than 5%. So there's a significant difference between the age of people in the Bronx and Manhattan, right? But not between the Bronx and Brooklyn, or between the Bronx and Queens, that's still over 25, and the Bronx and Staten Island still is that also is different than Staten Island, right? So my guess is that Manhattan and Staten Island are not going to be different from one another. Is Manhattan and Staten Island, right? They're not different enough, right? Okay, for us to reject the hypothesis. But look, Manhattan is different than everybody except, it's statistically different from all the other boroughs except Staten Island, right? And Staten Island is similar result, right? They're different from everybody else. So if you look at the box plot, at the, where is it? There we go. Okay, so here's the medians, right? Here is the median value for Manhattan and the median value for Staten Island. Look how different the others are. Right? Look at the variability though. Part of this is partly skewed too because it's not a great survey for this kind of stuff. Because notice there's nobody here under what age? Under 18. Yeah, because that's part of it. So it had to be adults to be in the survey. The first part here is the first quartile. That's the lowest 25% in age. Then this is the 50th percentile. That's the median, the middle value. And from here to the 25 percentile, right? Then from the median to here is the third quartile, 50% to 75%. And then this is the other 25%, right? So the blue box is the interquartile range. It's the middle 50% of the people. So the middle 50% of people in the Bronx are between about 37 years old and 60 years old. 25% of them are older than 60. That's a pretty significant amount. Right? That's pretty old. A lot of old geezers. Queens. Okay. So yeah, so that's the idea. And in addition to these data sets, we've given you some others as well. I keep saying we because I keep acting like Levi's still here. Yeah. I want him to come back. I miss him. Yeah, I miss having Levi around.
Yeah, in the video, he's teaching it here in the back.
Right. Yeah. Yeah. We switch off. He'll do a lecture and I'll do a lab and we switch back and forth. Yeah. We talk about it. Yeah, we'll chatter back and forth. Yeah. Hopefully. Yeah, he's on Facebook and he's also, he posts on Facebook and stuff like that. He's teaching in Italy right now. So I should drop a line.
Bonferroni.
Yeah, Bonferroni. He hasn't been pasting that much lately, but I hate when they go there to Italy and they paste pictures of food. Drives me crazy. Okay, so let me go back here to the project option. Oh, I'm in it already. Oops, shouldn't have done that. Okay, well, maybe it didn't take. Okay, so you can see there's other databases here. And some of them are coded, some of them are not. This is a comma delimited file. There's a Framingham study. That's that famous study that involved doctors and smoking and heart disease, right, and other factors and so on. It's a very large data set. There's a code book for it, documentation. You can play around with that if you want. You can look at these if you want. If you feel adventurous, remember, you're going to wind up having to do something. You're probably only going to wind up picking a few variables out. Even though they're enormous studies, you're probably only going to narrow it down to a few variables, but you're going to have to code it yourself because they're not coded. The only one that's coded already is the one that we gave you there, okay? So yeah, you got all sorts of junk here, right? So, and then submit your project description. If you want, oh, that's hidden. I didn't make that variable. If you want, you can put your project description on Blackboard, on the discussions board. Okay, where is it? I thought I updated this. No, I haven't updated this. Okay, hang on a second. Watch this. You can watch the magic happen. Okay. 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 You're right. Okay. Okay, so we have that there. I want to put one more up there. And exam 3. Questions or clarification. Questions, clarifications, or corrections. Okay, so that's available now in that area. If you want, if you have like if you wind up using one of those other databases, and you say to yourself, "Gee, I hope I'm doing this right. I don't want to get it submitted and I didn't use the right test or something like that." If you put onto the discussions board what you're doing, what you're planning on doing, I can give you some feedback and say, "Gee, you maybe want to consider doing analysis of variance instead of chi-square or something like that." Or maybe I might say, "Well, in order to do that, you don't have enough people, you don't have all of the, you have to have at least 5 people in each group or something like that." Maybe that's something I can contribute, or maybe even make a suggestion, make it easier for you or something like that. So or tell you not to get too crazy or something. Right? So so you have that option. You have the exam, or you have that option. The rules on the exam are basically the same. And basically, the exam, you won't be doing anything different than what we've done in class or in the one extra homework that I've added. Yeah, there's one extra homework there. Okay, that's number 7, correlation, and there's literally just one problem. One problem in like 6 or 7 parts. Like asking you to fill in the slope and so on and so forth. So it's really not very challenging. And there's a data set for it. You could do one or you could do several. It depends on what you get in your head what you want to show. I mean, really, the real idea is to use statistics to do something, right? So if you need 3 tests to demonstrate that, do 3 tests. If you can demonstrate it in one test and you found something interesting, that's great. Okay, found something interesting to enlighten us about vaccination, about poverty, about nutrition, about find something interesting to enlighten us about. You know, that doesn't matter if you do 3 tests or 10 tests or 1 test, right? Sometimes 1 is enough because that's what you needed to demonstrate what you were trying to show. Okay?